Now, I will give an overview of the batch reactor. The batch reactor is a type of vessel which is widely used in a process industry. In a batch reactor, the reactant and the catalyst is placed in the reactor and the reaction is allowed to proceed for a given time. In a viewpoint of thermodynamics, the batch reactor is a closed system where in a batch reactor there is neither inflow or outflow of the reactants or product while the process is being carried out. The operation is under a steady state where the composition is changed throughout the time. However, at any instant, the composition of the products in the reactor is uniform.
Hi, now we are here at Reaction Engineering Laboratory. As you can see here, safety start here. So I will talk about lab safety rules. And the first and foremost lab safety rule is conduct yourself at a responsible manner at all times in the lab. And secondly, you only need to perform the only those experiments authorized by the lecturer or technician, and definitely unauthorized experiments are not allowed, and do not eat or drink beverages and smoking in the lab. Next, the contact lens should not be worn in the lab, and you must dress properly during the lab activity, and the long hair should be tied back, and dazzling jewelry or baggy clothes must be secure, and shoes must be completely cover the foot, and no sandal allowed on the lab days. And lastly, a lab coat and glove should be worn during the lab activity, and if the experiment involved in chemical substances, and the mask, it is necessary to wear the mask. Okay, before start the experiment, you should be prepared for your work and read through all the procedure so that you can understand what you are doing, and then never fool around in the lab because it is dangerous, like horseplay, practical jokes and pranks are prohibited, and be alert and proceed with the caution at all times in the lab, and notify the lecturer or technician immediately if any unsafe condition are observed. After that, dispose all chemical waste properly. Never mix chemical waste with sink drains. Sinks are used for water only, and keep hands away from face, mouth and eyes and body while using chemicals or lab equipment. And after all the experiments are done, keep your hands with soap and water.
I'm going to introduce to you to each and every component that consists in the batch reactor system. First and foremost is hot water circulator. The purpose of hot water circulator is to control or maintain the temperature in the batch reactor system. The hot water circulator consists of heater, water, temperature sensor and the level sensor. The water can be filled through here and must be up until here to ensure the volume of the water is sufficient to circulate in the batch reactor. Next, I will explain about the flow of water inside the hot water circulator. The water inside the hot water circulator will be go through the outlet of the hot water circulator and flow to the batch reactor. Then the water will be come out and flow into the hot water circulator through the inlet. Next is the batch reactor. So this is how batch reactor look like. This is batch reactor. To charge reactant in it, we can open and pour the solution through here. So as we can see here, this is the stirrer, and this is a coiler to heating up purpose, and this is the temperature sensor. So that is all about batch reactor. Thank you.
Throughout the experiment, the students were using salted batch reactor. The purpose of this experiment is to study the effect of temperature towards the reaction rate constant. In addition, the batch reactor is used to study the activation energy and also the pre-exponential factor. The reactants being used throughout the experiment are the sodium hydroxide and the ethyl acetate, and the product being produced in the experiment will be the sodium acetate and the ethyl alcohol.
This is preparation of material procedure. First, the weight of the beaker was measured. Second step is zero button was pushed to eliminate zero error. Next, solid sodium hydroxide were weighed to 2 gram. 500 ml of distilled water was measured for dilution purpose. The solid sodium hydroxide and distilled water was mixed and stirred. Last but not least, 500 ml ethyl acetate was measured.
Throughout the experiment, the students were using salted batch reactor. The purpose of this experiment is to study the effect of temperature towards the reaction rate constant. In addition, the batch reactor is used to study the activation energy and also the pre-exponential factor. The reactants being used throughout the experiment are the sodium hydroxide and the ethyl acetate, and the product being produced in the experiment will be the sodium acetate and the ethyl alcohol. Both sodium hydroxide and sodium acetate are conductive. However, sodium hydroxide is a stronger ionic compound than the sodium acetate, which resulted in a higher conductivity. The decrease in the conductivity as the reaction proceeds with time indicates that the decrease in the concentration of sodium hydroxide in the reaction, and it also indicates the increment of sodium acetate throughout the experiment. In addition, from the tabulated data, it can be observed that the temperature is inversely proportional to the conductivity. As shown in the tabulated data, at higher temperature, which is the 40 degrees C, the conductivity is lower compared to the conductivity in the lower temperature. Therefore, when the temperature increases, the conductivity will decrease. Since sodium hydroxide being consumed in the reaction, therefore its concentration will be declined over time, and it can be observed in this figure.
From the raw data of the experiment, the value of 1/C can be calculated and a graph can be plotted against time, which is shown in this figure. This graph can be used to determine the rate of reaction. The regression line can be found, and according to the rate reaction equation, which is 1/Ca equal to Kt plus 1/Ca naught, the value of K is represented by the slope of the regression line. The regression line at 30 degrees Celsius shows a positive straight slope, while at 40 degrees Celsius shows a straight negative slope. Both of the graphs shows that the rate of reaction is accelerating at higher temperature. Therefore, the higher the temperature, the higher the rate constant as well as the conversion rate. So, the overall reaction rate can be determined by this graph, which is the gradient of this graph, and by using the integrating method.
Okay, after the reaction rate of constant was determined for temperature 30 degrees Celsius and 40 degrees Celsius, the reciprocal of temperature 1/T and natural logarithm of reaction rate constant ln K were calculated as shown in this table. After that, a graph of ln K against 1/T was plotted. In this graph, the relationship between these two variables is inversely proportional to each other. Therefore, by increasing the temperature, the reaction rate constant also will increase. Other than that, from the graph, the slope of the graph is equal to negative E/R, which is E is activation energy and R is gas constant, and it will give the value for activation energy and pre-exponential factor A.
In conclusion, first, the concentration of sodium hydroxide will be decreased due to its reaction with the ethyl acetate to produce sodium acetate and ethyl alcohol.
The second one, the conductivity of the reaction is inversely proportional to the temperature.
And the last one is the reaction rate constant is directly proportional to the temperature.
So that's all from us.
Thank you.
Bye.